Hey Finxters, and welcome to this espresso break Python, where I want to explain some very interesting Python concepts to you. They are called short-circuiting and Boolean, implicit Boolean type conversion in Python. So these two concepts are they are very relevant for many Python applications, and many advanced Python coders use them like naturally, intuitively, and many beginner coders actually struggle understanding these features. So I will explain them in this video, and I think you'll get a lot out of them. So keep watching, and let's dive right into the content. So suppose you have some Boolean operation like the OR operation, okay? So I say Boolean operation because usually you perform this operation on some Boolean values. Like you can have the true value, which is one of the two Boolean values, true and false, and you can use the OR operation to combine those two. Okay, so this OR operation, it's a binary operation, so it takes two operands. The first one is the operand true, for example, can be a Boolean value, and the second one is the Boolean false. And you use these operands to combine them with the OR operation. Okay, the OR operation is true if both operands evaluates to true. So far so good. Most people understand the logical OR operation, right? And we get a Boolean value out of this. And so, for example, if you have false or false, then we get the false. So nothing unexpected until now. But now, so many coders actually do the following. So they may use something like this. We can have an empty list or a string. So what does this mean now? Yeah, so we again have the OR operation. It's still the binary, it's the same binary operation, but now we use the logical OR operation on two non-Boolean values. So how does this work now? In Python, so now you have to understand two things. First of all, you can use any object as a Boolean value. So any object has a default Boolean conversion. Yeah. So and this default Boolean conversion is implemented in the __ bool method. So this method is in Python. Everything is an object. So every integer, every string, every list is an object, and each object has this method, this bool method implemented per default, and you can override this or you can just use the default one. Okay, and so if we go back to our example, so therefore we can use any object like an empty list or a string value, and we can simply theoretically rely on Python to implicitly convert this to a Boolean value. Okay, and now before we maybe go into this, let's have a look at the explicit conversion. So we can use the bool function to explicitly convert the empty list to a Boolean value, and you see the empty list is converted to a Boolean false. So what happens if we have a list with one element? It is converted to Boolean true. If you have a list with 3 elements, it is converted to the Boolean true. Okay, so you can see the implicit Boolean conversion associates the Boolean value false only to the empty object in many cases. So like per convention, of course you can overwrite it for your own custom object, but per convention the empty object, whatever it is, so if it is a collection type, then the object can be empty, can be an empty collection, is associated to the Boolean value false, and all other non-empty types are associated to the Boolean value true. This is exactly what we see here. And also we can convert strings. So the empty string, for example, to a Boolean value. The empty string would be associated to the Boolean false, and all other strings, even the string false, will be converted to the Boolean value true. Okay, so all non-empty strings will be converted to the Boolean true, and all empty strings will be converted to the Boolean value false. And again, we can convert for all numerical values. So the numerical values of 0 are associated to the Boolean false, and all numerical value that are either smaller or larger than 0 are converted to the Boolean value true. Okay, so you see this is the rule. So all 0 values and all empty values objects are converted to the Boolean value false, and all other objects are converted to the Boolean true. So if you have to take a guess and you don't know, then just guess that the conversion will result in a Boolean true. Good, so so far so good. So now you know about the implicit type conversion of Booleans. So for example, you can do something like this. If so, you can define an empty list, for example, yeah, or a list, and maybe let the user define the list or so, or load the list from memory or from a data set. And now you can check if the list is empty, then so if the list is not empty, because now it will implicitly be converted to the Boolean true if it is non-empty, then we print say something, and otherwise we print nothing. And you see now it is printed nothing because the list is empty. So therefore, you see the if condition expects a Boolean expression, but it's just you just pass an object like a list, and the object is now implicitly converted to the Boolean value associated to this object, and this is like false for an empty list. Okay, so now you know this, but let's go back to our example of the empty list or high. So in this case, we know that the empty list will be associated to false. So maybe we should execute this first so that you can see what is the result. Okay, now we have this OR operation on two operands. The first operand is the empty list. The second one is a string of two characters, h and I, so high. And now the result of this OR operation is not a Boolean value. It is the second operand, high. Okay, so this is strange. So what happens if we do it the other way around, like high or empty list? Now we still get high as the result of this operation. And why is that? Why do we get high as the result of the operation? So the reason is that, so let's go back to the first example, that the empty list is implicitly converted to the Boolean value false. And now the second so because the OR operation is only true if one of the operands is true. Now we know at this point Python goes from left to right. It sees this one is evaluated to the Boolean value false, implicitly converted to the Boolean value false. Now it doesn't even look at the second operand, because now the whole operation would be associated to true if the second operand is true. And the whole operation would be associated to false if the second operand is false, right? Because the OR operation is only true if at least one operand is true. So the second operand now, at this point, because we already know that the first operand is false, so therefore we know that the second operand determines whether this operation is false or not. So we simply return, Python simply returns the second operand. This is an optimization called short circuiting, because it allows us, so it doesn't evaluate the unnecessary part. So even if this expression would be, the second expression would be extremely complicated, there's no need to even evaluate the second operation. We can just return it, throw it away. So it is like an efficiency and optimization. So for example, if this would be an AND operation, and the first operation is already false, then we don't even need to look at the second operand. We don't even need to evaluate the second operand. Okay, so these together, those two optimizations, the implicit conversion and the short circuiting, lead to this strange behavior where simply the second operand is returned. So therefore, the OR operation doesn't return a Boolean value all the time. It simply returns the type of operands, the type of the operands you pass into the operation. So if you use like lists, if you use strings, if you use numerical values, then those values will determine the type of the output of your result. And you can even have like heterogeneous operands like this. Here we have a list object and here we have a string object. And now in some cases the list will be returned, in some cases the string will be returned. So you don't even know the type of the return type of the OR operation in this case. Okay. So for example, in this case we have the first one evaluates to false, so therefore the second one determines the overall result, and the second one is then just returned. And yeah, so and if the second one would be like non-empty, in this case we have the second one is the first one is a list with one element, so this evaluates to true. So therefore it doesn't even need to evaluate the second operand. It already knows that the OR operation is like is associated to true, so it simply returns the first operand. Okay, and in this case, therefore, the return value would be this list. So this is quite useful. In many cases, you can write very concise code. Yeah. So for example, you could use this statement in an an if statement like this, print hello world, for example, and now you see now it makes sense why it should be used like this. Yeah, so you can basically you can do some conditional, even some conditional assignments. So if you execute this, we get hello world, right? Because the result of this OR operation, it evaluates to true, but we don't need to explicitly convert it to the Boolean value. And you can do even some assignments, like we assign, so say we load a list from some user or from the memory, I don't know, so or from file. So we can load some list, store it in the variable L, and now we can set we can assign L to so we can assign L to the variable name X, but if L is empty, then we want to, so only if L is non-empty, we want to assign it to the variable X. But if it is empty, then we want to assign this default list. So therefore we can use some default expression. Now X takes on the default value if the list is empty. But what happens if the list is like has, say, 3 elements? Now we can use the same expression here. And now if we look at the variable X, it contains a list, okay? So this expression now basically means assign the value of the list L to the variable X, but only if it evaluates to true. So only if the list is non-empty. If the list is empty, then assign the default list 1 to the variable X, for example. So you can do really advanced Python one-liners. So this one is like the most concise way of doing some conditional expression like this. So it's very Pythonic. It's often used by advanced coders, and I think it's very useful for you to know the short-circuiting optimization in Python. And it works similarly for the AND operation, only that the AND operation simply returns. So if the first operand, so maybe we can have an example, quick example. So we have the empty list and high, and the return value is the empty list, right? Because the empty list already evaluates to false, so there's no need to check out the second operand. So therefore we simply return the first operand, and this is the output. And if the first operand is like, say, first one is a list with 1 element, so this one would evaluate to true, and now it simply returns the second operand, because this evaluates to true, so therefore the second operand determines the overall return value of the list, so therefore it simply returns the second operand. Okay, so this is how the AND operation and the OR operation can be applied to arbitrary objects and used for some conditional assignments. Yeah, so for example here you have seen this with the OR operation to conditionally assign a list to a variable, and if the list is empty, we assign another default list to this variable. Okay, so thanks for watching this video. If you are interested in Python one-liners, then check out my book, Python One-Liners. It will make you a master of the single line of Python code. Also, if you want to earn some money as you learn Python development, then check out my free webinar. I give a link in the description below, how to build your high income skill Python, getting paid in the process. So by learning Python, you will basically develop some practical code projects for clients as a freelance developer and get paid in the process. And also check out my course, and I will give link to all these resources in the description below. Thanks for watching, and see you in the next video. Bye.